all. Welcome to Unacademy. Today we will see our next topic from the differential equation. Today we will see our next topic, the differential equation, or next point from the differential equation. In the last lecture we have seen how to solve the linear differential equation with constant coefficient. Okay. In that we have seen the three rules, method 1, method 2 and method 3. Okay. So method 1 is our general method. Method 2 is shortcut method. In that we have already covered up 6 rules how to find out the differential equation. Okay. Now in that how to find out the solution for the differential equation. Third one is also we covered. It is method of variation of parameter. Okay. Now in this lecture we will cover how to solve the differential equation if it is in the form of Cauchy's differential equation or Legendre's differential equation. Okay, that we will see in this lecture. Now see, first we will before going to start this, I will introduce myself. Myself Dhanashree Palasdeokar. I completed my MSc in Mathematics from Mumbai University and also having a 13 plus years of teaching experience, and I also mentored more than 10,000 plus students for the engineering. Now I'll give brief introduction how to install the Unacademy Learning app. First, step 1, go to your mobile's Play Store app and then see the Unacademy's Learning app, type Unacademy's Learning app. See the arrow is blinking like this, you will get like this and install that. Second step, install the Unacademy's Learning app. Third is you have to manage your goal, that for which courses you want to study, that you have to manage your GATE and ESE hai, or NET hai. Okay, many courses are available. You will search or you will manage your whatever you want to study here. Then take the subscription, either it is plus subscription, free courses or special classes. After that, you press the get subscription button so that you will get subscription of the Unacademy's Learning app. And the most important thing here I am going to tell you, if you want a 10% subscription on your subscription fee, then you use my promo code, that is DSP, then you will get 10% discount on it. Now next is Unacademy. After getting that, you will pay your subscription fee by any one of these methods, either by debit card, credit card, EMI, UPI, wallets, net banking, anything you can see here. Now let's start our actual topic. It is equations reducible to linear differential equations with constant coefficients. Okay, equations reducible to linear differential equations with constant coefficient. Now first is Cauchy's or Euler's homogeneous linear differential equation. An equation of the type P0 x raised to n, p raised to n into x raised to n raised to n upon dx raised to n plus p1 x raised to n minus 1 dx raised to n minus 1 d raised to n minus 1 upon dx raised to n minus 1, then plus p2 x raised to n minus 2 d raised to n minus 2 upon dx raised to n minus 2 plus and so on, plus pn of y is equal to x, where p0, p1, p2 up to pn are constants. It's called the Cauchy's linear differential equation. If you see the linear differential equation is in this type, then which implies this can be reduced into linear differential equation with constant coefficients by using the substitution. What we will do, there is no any rule to find out the solution for this Cauchy's differential equation. So what we will do, we will first of all convert this Cauchy's differential equation into linear differential equation with constant coefficient by using the substitution x is equal to e raised to z and z is equal to log x and d by d is equal to d by dz. Okay, so what will be giving you here, see x0, p0 x raised to n, d raised to n upon dx raised to n. So your equation becomes, now see, Once you are writing here x is equal to e raised to z, see, x is equal to e raised to z, x is equal to e raised to z, then put z is equal to, which implies z is equal to log x, okay, which implies z is equal to log x, and here d is equal to d by dz, d is equal to d by dz, so you will get dy by dx is equal to, now we will require here dy by dx, okay, so what we will do, we will apply the chain rule, see, dy by dx, dy by dx is equal to, we will get dy by dz into dz by dx, okay, dy by dz into dy by dx is equal to dy by dz into dz by dx, so you will get here dy by dx is equal to, now dy by dz into, what is our dz by dx here, see, once you put here x is equal to e raised to x, which implies z is equal to log x, so dz by dx is equal to 1 upon x, so that's only we are putting y, okay, so this is our reducible form of a Cauchy's differential equation into linear differential equation. Now you see, wherever there is x into dy by dx, wherever there is, so the previous case, second last case of this differential equation is x d by dx, so wherever there is x dy by dx, we can use here d into y, directly we will do the substitution, x into dy by dx is equal to d into x, you will get d2y by dx square, here you will get d2y by dx square into, so use u into v rule, d by dx of dy by dz into 1 upon x, okay, so dy by dz you will get here dy by dz into dz by dx into 1 upon x, okay, so into 1 upon x, first into, so first differentiating derivative of first, so that is d by dx of d by dy by dz into 1 upon x, okay, writing here separately, d2y by dx square is equal to by dx of 1 upon x into dy by dx, 1 upon x into dy by dx. So here you will get the first into derivative of second with respect to z and z with respect to x, plus derivative of second is minus 1 upon x, derivative of 1 upon x is minus 1 upon x square into dy by dz. So you will get 1 upon x into d2y by dz square into dz by dx plus minus 1 upon x square into dy by dz. Now here d2y by dx square is equal to 1 upon x square. Here see, dz by dx is 1 upon x. That 1 upon x and into this 1 upon x becomes 1 upon x square into d2y by dz square minus 1 upon x square into dy by dz. Okay, we will take 1 upon x square common, so you will get 1 upon x square into bracket d2y by dz square minus dy by dz, right, d2y by dz square minus dy by dz. So here you will get, now I am transferring this x square to the LHS. So x square into d2y by dx square is equal to d2y by dz square minus dy by dz. So d by dz, as we have already said, d by dz is equal to capital D, that is our differential operator. So d square minus d of y is equal to d into d minus 1 of y. So wherever in the Cauchy's differential equation this term becomes x square into d2y by dx square, we directly apply d into d minus 1 of y. Okay. Similarly, we will directly apply here x cube into, so if you differentiating this equation again with respect to x, if you differentiating this equation again with respect to x, so you will get d by dx of d2y by dx square, that is d cube y upon dx cube into, again here u into v rule first, because z is a function of x again. So 1 upon x square into d2y by dz square into dz by dx. So you will get d2 dz by dx d cube y upon dz cube into, see I am explaining here only, d cube y by dx cube is equal to dx 1 upon x square into d cube y upon dz cube into dz by dx plus minus 1 upon, so derivative d plus d2y by dz square and into derivative of, I am only finding out the derivative multiplication, derivative of this multiplication term. So d2y by dz square into, here derivative of 1 upon x square. So derivative of 1 upon x square, that is derivative of x raised to minus 2. So minus 2 into x raised to minus 3. So can I write here minus 2 upon x cube? So derivative of this. Okay. So I'm just find out the derivative of here. Okay. Minus. Again 1 upon x square into dy by dz. So first into derivative of second, that is d2y by dz square into dy by dz into dz by dx. Okay, plus dy by dz into derivative of again 1 upon x square. So it is minus 2 by x cube into dy by dz. Okay, so we can find out the after simplification this. So dz by dx, sorry, here dz by dx, but dz by dx is nothing but 1 upon x. So this 1 upon x and this 1 upon x square becomes 1 upon x cube into d cube y upon dz cube plus d2, see minus 2 by x cube into d2y by dz square. Okay, and this minus 1 upon x square into dz by dx again becomes 1 upon x. So this will your minus 1 upon x cube into d square y upon dz square and minus 2 by x cube upon dz by dx. So again taking x common, 1 upon x cube common. So dy by dz by dx again becomes here c. So minus 1 upon x cube again. Okay. So minus 1 upon x cube into dz by dx. So minus 2 upon x cube. So after taking that common, so you will get d into d minus 1 into d minus 2 of y. So whenever in the differential equation, the Cauchy's differential equation, the terms comes x cube d cube y by dx cube, you can directly write down d into d minus 1 into d minus 2 of y. Okay. I hope you are clear here how to convert the given Cauchy's differential equation into linear differential equation with constant coefficient. Okay. The given Cauchy's differential equation into linear differential equation with constant coefficient. Okay. Now, so similarly, if the differential equation contains the term x raised to 4 into d raised to 4y upon dx raised to 4. Okay. Contains dx raised to d raised to 4, x raised to 4 into d raised to 4y upon dx raised to 4 is equal to, so you will get d into d minus 1 into d minus 2 into d minus 3 of y. Okay. D into d minus 1 into d minus 2 into d minus 3 of y. So we will take this term, or we will consider this equation. For this term we will write this one. Okay, so whenever there is, see, if you observe here in the previous steps, so whenever there is x into dy by dx, directly we can write d into y. Okay, whenever there is x square d2y by dx square, we write d into d minus 1 up to y. So x cube d cube y by dx cube d into d minus 1 into d minus 2 of y. So x raised to 4 into d raised to 4y upon dx raised to 4 is equal to d into d minus 1 into d minus 2 into d minus 3 of y. Okay. Now, see, we will see x raised to 4 into similarly and so on. In short, x dy by dx is equal to dy, x square d2y by dx square is equal to d into d minus 1 of y, x cube d cube y by dx cube into d minus 1 into d minus 2 of y, and so on, which can be solved lastly and resubstitute the value of z is equal to log x. So lastly we will resubstitute it, the value of z is equal to log x. Okay. Now next is exactly similar type, we will see the legendary linear differential equation. Okay. And the differential equation in the form of ax plus b bracket raised to n into d raised to ny upon dx raised to n plus p1 ax plus b into raised to n minus 1 into d raised to n minus 1 upon dx raised to n minus 1 plus p2 ax plus b bracket raised to n minus 2 into d raised to n minus 2y upon dx raised to n minus 2 plus and so on, pn y is equal to 0. Okay, plus and so on, pn of y is equal to x, sorry not 0, is equal to x, where p1 p2 up to pn are constant and is called as a linear differential equation. This can be reduced into the linear differential equation with constant coefficient. Again the same substitution here, instead of x is equal to e raised to z, we will use ax plus b is equal to e raised to z, where z is equal to log of ax plus b and d by dz is equal to capital D. Okay. Now, then ax plus b into dy by dx is equal to a dy. And explaining you this term, how to reduce it. See, ax plus b, here ax plus b is equal to e raised to z. So, which implies z is equal to log of ax plus b. Z is equal to log of ax plus b, and then z by dx, you will get dz by dx is equal to log u 1 upon ax plus b into derivative of x plus b is a. Z by dx is equal to this. Now we will take dy by dx. So dy by dx is equal to, you will get dy by dz into dz by dx. Right? So here dy by dx is equal to dy by dz. So dy by dz into dz by dx. dy by dz into dz by dx. But dz by dx is a upon ax plus b. Okay. So we will transfer this dy by dx. Here, a dy by dx is equal to this. So I am transferring this a into ax plus b to LHS. So ax plus b into dy by dx is equal to a into dy by dz. But as we know that d by dz is d, so you will get wherever there is a into ax plus b into dy by dx term is there, we can directly substitute a into dy to convert it into linear differential equation with constant coefficient. Okay, so ax plus b into dy by dx is equal to a into dy. Now here, for example, suppose solve x cube into d square y and so on. So here the lastly we will get in that form a cube. See, in the Cauchy's we will get only d by d into d minus 1 of y, d into d minus 1 into d minus 2 of y. But in the legendaries we will get a into d by a square into d minus 1 of y, a cube into d minus 1 into d minus 2 of y, and so on. Okay. Now, and lastly, resubstitute the value of z is equal to log of ax plus b, exactly similar to the Cauchy's differential equation. Okay. Now we will solve this. Now, after observing this differential equation, what it indicates? See, definitely it is not directly the Cauchy's differential equation. Okay. In the Cauchy's differential equation, the order is same, x raised to n into d raised to n y. X raised to n, right? X dy by dx. Here the order is not same. Here is n, here is n. But here is 3 and here is 2. So what we will do? First we will convert out. See, here is 2, here is 1. So this is not same, look like exactly similar to the Cauchy's differential equation. So what we will do? We will first we'll first divide this differential equation by x. So you will get x cube. So divide by x. Divide by x. So you will get x square into d2y by dx square plus 3x into dy by dx plus y is equal to 1 upon x into sine of log x. So call this as equation 1. Now if you observe, this differential equations looks like a differential equation, Cauchy's differential equation. Okay. Now see, to convert this into Cauchy's differential equation, so convert equation 1 is a Cauchy's differential equation. Equation 1 is Cauchy's differential equation. So to convert it into linear differential equation with constant coefficient, substitute x is equal to e raised to z. Okay, to convert it into linear differential equation with constant coefficient, substitute x is equal to e raised to z. So x is equal to e raised to z, which implies z is equal to log x. dz by dx is equal to 1 upon x. Now we will write x into dy by dx is equal to, directly now we can substitute here dy, and here x square into d2y by dx square is equal to d into d minus 1 of y. Okay, so d into d minus 1 of y. Now the highest term is only x square. Okay, so your equation 1 becomes so therefore equation 1 becomes, क्या हो जाएगा हमारा differential equation? X square d2y by dx square, it means d into d minus 1 of y plus 3 into x dy by dx. So instead of x dy by dx, we will put dy. So 3 dy plus y is equal to 1 upon x. So here x is equal to e raised to z. So here e raised to z into sine of log x. So your sine of log x, but log x is equal to z. So sine z. Okay. So your differential equation becomes d into d minus 1 plus 3d plus 1 of y is equal to e raised to minus z into sine z. Okay, e raised to minus z into sine z. Now this will becomes d square minus d plus 3d plus 1 of y is equal to e raised to minus z into sine z. Okay, now so this will converted into d square minus d plus 3d, that is plus 2d plus 1 of y is equal to e raised to minus z into sine z. E raised to minus z into sine z. Now if you observe, your differential equation becomes a linear differential equation with constant coefficient. Okay, this is the general form of the linear differential compared with the general form of the linear differential equation with constant coefficient. Now it is converted into this form. So now we will solve this differential equation with constant coefficient by using our usual rules. Okay, now yesterday we have seen how to find out the solution for the given differential equation with constant coefficient. Okay, now here instead of x, your total differential equation is converted into the variable z. Okay, so we can write here auxiliary equation is d square plus 2d plus 1 is equal to 0. Okay, so d square plus 2d plus 1 is equal to 0. So is it nothing but d plus 1 bracket square is equal to 0? If you see, this is a complete expansion of a d plus 1, d square plus 2d plus 1 which is equal to 0. Now which implies d plus 1 is equal to 0, d plus 1 is equal to 0. So which implies d is equal to minus 1 minus 1. Now if you observe here, d is equal to minus 1 minus 1 are the roots of are the roots of given differential equation which is real and repeated. The roots are real and repeated. So which implies as the roots are real and repeated, therefore we can write f of, so yc is equal to here c1 plus c2 z. Now your differential equation in terms of z. So we will write c1 plus c2 z into e raised to minus z. Are you getting it? Now see, this is your yc. So called is, now this is your yc. Okay. Now we will find out the particular solution. Now yesterday we have seen the rule how to find out the solution for the given differential equation. If your x becomes x is equal to e raised to ax into v. So whenever there is e raised to ax into v, then how to find out the solution for the given differential equation. Okay, x is equal to e raised to ax into v. So which implies here, so yp is equal to, we can write yp as 1 upon phi of d or f of d into x. Now here instead of x, I am writing z because your differential equation in terms of z. Don't forget to write the z. Otherwise, if you write here x, your whole answer will be wrong. Okay, so yp is equal to 1 upon f of d into z. Okay, so it will becomes yp is equal to 1 upon f of d. So 1 upon f of d is your d plus 1 bracket square. D plus 1 bracket square into z. So z is your e raised to minus z into sin z. Okay. Now see, if you observe, this is the, here we can apply, which rule we can apply here? Rule 5. Okay. Rule 5, that is e raised to ax into v rule. E raised to ax into v rule. Okay. So yp is equal to here, तो क्या है हमारा रूल, e raised to x into v का, so replace d by d plus a here. Okay, replace 1 upon f of d plus a into raised to az to f of z or into z. Right? So that is our rule. Here your d is, here I am replacing your d is d plus a. So d plus, but here a is equal to minus a. So we can write d minus 1 plus 1 bracket square into e raised to minus z into sin z. Directly we can write here e raised to minus z into 1 upon. Now here plus 1 minus 1 get cancelled out. So you will get d square into sin z. E raised to minus z into 1 upon d square into sin z. Okay. So once we are getting this d raised to minus z into 1 upon d square into sin z. Now see, again here directly, see, there are two ways to elaborate this 1 upon d square. Either you can double integrate this or you can use the rule here 2, sin of ax वाला rule. तो sin of ax वाला rule क्या है, अगर हमारा फंक्शन f of x is equal to, अगर sin ax plus b और cos ax plus b है, तो we can replace b square by minus of a square. So here your a is equal to 1, a square is equal to 1, minus of a square is equal to minus 1. So instead of d square, we directly use minus e raised to minus z into 1 upon minus 1. Okay, 1 upon minus 1 into sin z. So 1 upon minus 1 into sin z. So minus e raised to minus z into sin z. Okay, minus e raised to minus z into sin z. So you will get here your final answer will be minus z e raised to minus z into minus e raised to minus z into sin z. That is your yp. Okay, now what's our next job is, write down y is equal to, your complete solution will be y is equal to yc plus yp. So y is equal to yc plus yp, so which implies y is equal to, your y is here, yc is here c1 plus c2z into e raised to minus z. 1 plus c2z into e raised to minus z. Okay, here c1 plus c2z into e raised to minus z plus yp is minus e raised to minus z into sin z. Minus e raised to minus z into sin z. Okay, now we will replace z by log x. Okay. So here c1 plus c2 into z is log x into e raised to minus z, it means e raised to minus of log x, it means can I write here directly, here 1 upon x raised to minus log of x, it means 1 upon x minus e raised to minus z, it means again 1 upon x, because x is equal to e raised to z, so e raised to minus z, it means 1 upon x into sine of z, it means log x. Okay, your final answer for the given Cauchy's differential equation. First we will convert it into linear differential equation with constant coefficient, and then you apply the same rules as we have discussed in the last lecture. Okay, differential equation 2, lecture in the differential equation 2. So we'll get the solution for that. Here y is equal to c1 plus c2 into log x into 1 upon x minus 1 upon x into sine log x. The example number 2. Now solve x square d2y by dx square plus x dy by dx plus y is equal to sine of log x square. Exactly similar way we will solve this example. So here you will get x square into d2y by dx square plus x into dy by dx plus y is equal to sine log x square. Again, now see, this is directly the Cauchy's differential equation. So here we can write the given differential equation is a, which is Cauchy's differential equation. Given differential equation is Cauchy's differential equation. To convert it into linear differential equation, to convert it into linear differential equation with constant coefficient, we use the substitution. X is equal to e raised to z. Z is equal to log x. Z by dx is equal to 1 upon x. Okay, we will, every time we have to write this. Okay. Now, and instead of x square d2y by dx square, we use d into d minus 1 of y. So d into d minus 1 of y plus dy plus y is equal to sine of 2 log x here. Can I write sine log x square? It means sine of 2 log x. So sine log x is equal to z. So sine 2z. Here you will get sine 2z. Okay. Now differential equation becomes d square minus d plus 1 of y. Then multiplying this d square y, that is square y minus dy plus d plus 1 of y is equal to sine 2z. Okay, so plus d minus d get cancelled out. So d square plus 1 of y is equal to sine 2z. d square plus 1 of y is equal to sine 2z. So what you will get? D square plus 1 of y is equal to sine 2z. It means here we will this differential equation is converted into linear differential equation with constant coefficient. Now if you see your f of z is nothing but the, here we will apply the rule 2 to elaborate this differential equation or to find out the solution for this linear differential equation. Now let's start. So your first auxiliary differential equation is here. Auxiliary equation is d square plus 1 is equal to 0. So which implies d square is equal to minus 1, which implies d is equal to plus or minus I. Right? D is equal to plus or minus I. So roots are complex. So you can write down here y your yc is equal to, so alpha is equal to here 0, so e raised to alpha x, it raised to 0x even to c1 cos beta x plus c2 sin beta x, but here beta is equal to 1, alpha is equal to 0. So I can write here directly e raised to 0x, it means 1, so no need to write down. So c1 cos z, now instead of x we will write z, c1 cos z plus c2 sin z. Okay, here yc. Now we will find out yp. Now we will find out yp here. So what is our yp? Yp is equal to 1 upon f of d into z. So 1 upon f of d is d square plus 1, right? And your z is sin 2z. So very simple. We will apply here now rule 2, sin ax का rule हम लोग apply करेंगे. If your x is equal to sin ax, then replace d square by minus of a square. So here your a is equal to 2. Now this is your a. So a is equal to 2. A square is equal to 4. Minus of a square is equal to minus 4, which is equal to 1 upon minus 4 plus 1 into sin 2z. 1 upon minus 4 plus 1 into sin 2z is equal to 1 upon minus 3 into sin 2z. 1 upon minus 3 into sin 2z. Okay. Now here, so this replaced, this is your yp minus 1 by 3 into sin 2z. So yp is equal to 1 minus 1 by 3 into sin 2z. This is your yp. Now we will write our final solution. Y is equal to yc plus yp. The final solution, y is equal to yc plus yp. So yc is c1 cos z plus c2 sin z. c1 cos z plus c2 sin z plus, here your yp is minus 1 by 3 minus 1 by 3 into sin 2z. No? Minus 1 by 3 into sin 2z. Now finally see your differential equation in the form of x. So you have to write the solution in form of x. So again replace z by log x. Here y is equal to c1 cos log of x plus c2 sin log of x minus 1 by 3 sin 2 into log x. Generally directly we can write down here y is equal to c1 cos log x plus c2 sin log x minus 1 by 3 into sin log x square. This is your final answer for the given Cauchy's differential equation converted into linear differential equation with constant coefficient. Okay. Next. Now, after observing the differential equation, so can you guess which type of this differential equation? Yes, can anybody having the guess that which type of this linear differential equation? Is it nothing but your, if you observe, is it nothing but your ax plus raised to n into d raised to n upon d raised to ny upon dx raised to n. Now, if you compare this differential equation with Legendre's differential equation, you'll get the exactly symmetric difference, exactly same to the Legendre's differential equation. Okay, so can I write this as this is your freedom? This is Legendre's differential equation. So to convert it into linear differential equation, convert it into linear differential equation with constant coefficient, we use x is equal to e raised to here ax plus b. Here ax plus b is equal to e raised to c. So which implies z is equal to log of ax plus b. Implies z is equal to log of ax plus b. Okay, so z is equal to log of x plus b, so which implies dz by dx is equal to a upon 1 upon log u, so that is ax plus b into derivative of u, that is a. So dz by dx is equal to, you can write a upon ax plus b. Okay, and we will use the differential operator, that is d by dz is equal to capital. Okay. Now this is the mandatory thing you have to write in any Legendre's differential equation. Okay. Now after that you will get converted into the given Legendre's differential equation into linear differential equation with constant coefficient. We will write here ax plus b into, so we can directly write down here ax plus b bracket raised to, so d raised to 2 y upon dx square is equal to d into d minus 1, a square into, exactly similar to that, a square into d into, or then you can write first dy by dx is equal to a into dy, or then x plus b d2y by dx square is equal to a square into d minus 1 of y. Now at the most here the order of the differential equation is here 2. Now in this case here a is equal to, so we will put 2x plus 1 into dy by dx is equal to 2. Here a is equal to 2, so 2 into dy. Okay. Here we will use 2 into dy. So once you get here 2 into dy, so your differential equation becomes, so z is equal to, so directly we will write here 2x plus 1, z is equal to log of 2x plus 1, particular form. So dz by dx is equal to 2 upon 2x plus 1 by dx is equal to this. So 2x plus 1 dy by dx into 2 into dy, and 2x square 2x plus 1 bracket square d2y by dx square is equal to 2 square into d minus 1 of y. So 2 square is nothing. So 2 into 2 also we can write. So your differential equation is converted into this one. 2x plus 1 bracket square d2y by dx square, we can write 4 into d minus 1 of y plus 2 into 2x plus 1 dy by dx. So 2 into 2x plus 1 dy by dx is 2 dy plus 4y is equal to 4 into sine of 4 into sine of here log of 2x plus 1. Now log of 2x plus 1 is nothing but what? So can I write this as 2 into log of 2x plus 1? So your expression becomes 2z only. So sine 2z. Now this is simplest way. Okay? 4 sine 2z. I hope you are clear. How I write this? differential equation with constant coefficient. So you will get 4 into d square, 4 into d minus 1 plus 4d plus 4 of y is equal to 4 sine 2z. If you observe, here 4 is common to everywhere. So what I will do, I will take 4 common. So d square minus d plus 1 of y is equal to 4 into sine 2z. Now this 4 and this 4 becomes cancel out. So plus d minus d cancel out. So you will get d square plus 1 of y is equal to sine 2z. Now if you observe how simple this differential equation becomes. Now look your original differential equation and see how we converted this differential equation into linear differential equation with constant coefficient. Now it is very simple to now converted into a very simple differential equation, linear differential equation with constant coefficient. Now we will find out solution for this. We will use auxiliary differential equation. So auxiliary equation is d square plus 1 is equal to 0. So which implies d square is equal to minus 1, which implies d is equal to plus or minus I. Okay, so your auxiliary equation solution, that is yc is equal to c1 cos z plus c2 sin z. Okay, now we'll find out yp. So what is our yp? 1 upon f of d into z. So 1 upon f of d. So what is our f of d here? F of d is d square plus 1 into z, function of z, sin 2z. Again simple way, sin 2z. So here a is equal to 2. So you will get a is equal to 2, a square is equal to 4, minus of a square is equal to minus 4. So instead of d square, put minus of a square. It is your yp becomes yp is equal to 1 upon d square. That is d square is minus 4 plus 1. Minus 4 plus 1 into sine 2z. Right? So here is nothing but minus 1 by 3 into sine 2z. So this is your yp. So we can write the final solution. Y is equal to yc plus yp. So which is equal to c1 cos z plus c2 sin z minus 1 by 3 sin 2z. Minus 1 by 3 sin 2z. This is your y. Okay, but y in terms of z. So your last thing we will here use, we substitute z for log x. c1 into cos of log of, here what is our z? What is our z? Z is equal to log of 2x plus 1. Then we will write z is equal to log of 2x plus 1 plus c2 sine log of 2x plus 1 minus 1 by 3 into sine into 2 into log of 2x plus 1. Okay. So this is your final answer for the given Dhanashree differential equation. Okay. Now exactly similar way we can find out this. So here your x plus 1 is bracket square. So again it is Legendre's. So to convert the given differential equation is Legendre's differential equation. Legendre's differential equation. To convert it into linear differential equation with constant coefficient we will use the substitution. We will use the substitution here. X plus 1 is equal to e raised to z. So z is equal to log of x plus 1 and dz by dx is equal to 1 upon x plus 1. Right? We will get dz by dx is equal to 1 upon x plus 1 and d by dz is equal to capital D. So your linear differential equation, the Legendre's differential equation is converted into linear differential equation is like this. A square. So here a is equal to 1. A square into d minus 1 of y. Right? So here a is equal to 1. So only 1 square. So x plus 1 into dy by dx, you can write a dy means 1 into dy minus y is equal to 2 log x plus 1, it means 2z plus x. So your x becomes e raised to, see, x plus 1 is equal to e raised to z. So your x becomes e raised to z minus 1. So here we can write e raised to z minus 1 and plus 1. E raised to z minus 1 minus 1. So here d square minus d plus d minus 1 of y. 2z plus e raised to z minus 1 minus 1 minus 2. Okay. So here you will get into e raised to z minus 1 minus 2. So plus d minus d cancel out. You will get d square minus 1 of y is equal to 2z plus e raised to z minus 2. Now it is converted into the linear differential equation with constant coefficient. Okay. It is converted into linear differential equation with constant coefficient. So we will find out first auxiliary equation. D square minus 1 is equal to 0, which implies d square is equal to 1, which implies d is equal to plus or minus 1. Okay. As d is equal to plus or minus 1, so you will get yc is equal to e raised to c1 e raised to z plus c2 e raised to minus z, as roots are real and distinct. You can write yp as yp is equal to 1 upon f of d into z. Okay. Yp becomes, yp is equal to 1 upon f of d is d square minus 1, d square minus 1 into f of z is 2z plus e raised to z minus 2, 2z plus e raised to z minus 2. Okay. So 2z plus e raised to z minus 2. So what we will do, we will separate out this. So 1 upon d square minus 1 into e raised to z and plus 1 upon d square minus 1 into 2z minus 2. So I am separating this so that I can use the different rules here. So here e raised to z over e raised to z. So we can use the rule 1. Here e raised to ax. So here a is equal to 1. So if I put a is equal to 1, so this will become 0. So instead of that, we will do 2d into e raised to z. Z upon f dash of d to e raised to z plus here 1 upon d square minus 1. So instead of that, if I write minus of 1 minus d square. Okay, minus of 1 minus d square. So you will get, if the all signs are to 2z minus 2. 1 upon d square minus 1, I can write here 1 minus d square minus of 1 minus d square. So here again put a is equal to 1. So 2. So z by 2 into e raised to z minus 1 minus d square bracket raised to minus 1 into 2z minus 2. Now expand up to the highest power of x. You can expand this up to the highest power of x. That is, here we will use 1 plus z or 1 minus z substitute. Okay. Here we can use 1 plus z or 1 minus z. So what is our 1 minus z formula? If it is minus z, 1 minus z, 1 plus z and 1 minus z bracket raised to 1 minus 1. Then you can use here all the roots term. If it is converted into 1 minus z form, then we can use here 1 plus z square plus z cube plus and so on. All are positive. If it is plus, then it is alternate positive negative sign. Okay. So here you will get z by 2 into e raised to z minus d minus 1 minus d square bracket raised to minus 1. So expand up to the highest power of z. Here z highest power of d is 1. So only we can write 1 plus z. So 1 plus d square. 1 plus d square. So you will get 1 plus d square is equal to this. So ultimately, here directly write down 1 plus d square is equal to this. So 1 plus d square of 2z minus 2. 1 minus z का एक्सपांशन किया हमने अप टू द हाईएस्ट पावर ऑफ m. m की पावर है 1, तो एक ही किया 1 plus z. Okay. We'll get z by 2 into e raised to z minus 1 plus, so 1 into z minus 2, ये हो गया 2z minus 2 plus d square of 2z minus 2. This is second order derivative of this. Second order derivative z by 2 equal to z by 2 into e raised to z minus 2z minus 2 z minus 2 plus d square of z minus 2 plus d square of 2z minus 2. 2z minus 2 plus d square of 2z minus 2. We'll calculate here. Z by 2 into e raised to z minus 2z minus 2. So first order derivative क्या हो जाएगा यहाँ पे? 2z minus 2 का 2. Second order derivative क्या हो जाएगा? D square of this is 0. Okay. So d square of this you will get, here is derivative of this is only 2z minus 2. Derivative of this is 0 plus 0. So d square of 2z minus 2 is 0. Get z by 2 into e raised to z minus 2z plus 2. Your yp. You can write y is equal to yc plus yp. So your final solution y is equal to c1 cos z, c1 e raised to z plus c2 e raised to minus z, and e raised to z plus c2 e raised to minus z plus 2 by z into e raised to z minus 2z plus 2. Okay. Now replace e raised to z here. So y is equal to c1 to replace z by log of x plus 1. Then into e raised to log of x plus 1, it means x plus 1 plus c2 into e raised to log of x plus 1 bracket raised to minus 1. तो यहाँ पे minus 1 हो जाएगा plus yp 2 by z. So 2 upon z, it means log of x plus 1 into e raised to z, it means again log of x plus 1. Here z by 2, 2 by z, z by 2. Here z is log of x plus 1 upon 2 into e raised to z means x plus 1 to x plus 1 minus 2 into minus 2 into log of x plus 1 it means plus 2. This is your final answer. Y is equal to this. Hope you are clear here how to find out the general solution or how to find out the solution for the Legendre's differential equation with converted into linear differential equation with constant coefficients, and we will solve it by using substitution. Okay. So I hope you are clear here. So I completed your differential equation. This is very useful for the mechanical engineering, all the branches of the engineering. Okay. So I hope you are clear here. If you are liking my video, please do share, like and subscribe. Thank you so much. Thank you for the watching. Next lecture we will come with the calculus part. That is, in that part we will say the vector differentiation. Okay. Keep watching.